Alrighty, so 4.2, multiplying and dividing rational expressions. So 2 objectives, multiplying and dividing. Alright, so to multiply, what we need to do is factor everything out. After you factor out, you want to simplify. You're always going to be able to simplify. And that can either be crossing out common factors from the numerator and denominator, or cross-simplify, just like normal fractions. And then you want to multiply what you have left over. So for example 1, we want to multiply the rational expression x squared plus 7x over x squared times 4 over x squared minus 49. So the first thing we want to do is factor everything out. If we look at our first numerator, we have x squared plus 7x. They share an x in common, so we can go ahead and take that out right now. Alright, our first denominator of x squared is just x times x. Now numbers, you pretty much just leave them where they're at, so we'll just have 4. And next we have x squared minus 49. Well, that's a difference of 2 squares. So we'll have x plus 7, x minus 7. Alright, so if we look top and bottom, is there anything we can cancel out? Well, one of these x's, they share something in common. And now we look at our second one, nothing we can cancel out, top and bottom. So next you look diagonally. So diagonally, is there anything we can cancel out? Well, yes, these x plus 7s are identical. So let's write what we have left over. If we have nothing left, it's just 1. So on our first numerator, it's 1. And now we have x, and we're multiplying that by 4 and x minus 7. Now from there, once you cross-simplify, you simplify everything, you just multiply straight across. So we'll have 1 times 4 is 4. And we have x times x minus 7. I'm going to leave this as x times x minus 7. Or you can have 4 over x squared minus 7x. Both are correct. Alright, example 2. So example 2, we're still multiplying, but now we have trinomials. So we absolutely want to factor every single thing we can out. So our first trinomial, we know that they have a k in common. Everything has k, so let's go ahead and take that out. Alright, so we have k squared minus 1. That's a difference of 2 squares. So we can have k minus 1, k plus 1. Alright, next we have 9k minus 9. Well, they have a 9 in common, so we can take it out. So we'll have 9 times k minus 1. So for our last denominator, k squared minus 9k plus 20, we can go ahead and factor that out. So we'll have k minus 5, k minus 4. Alright, so if you notice, we can still factor out our first trinomial. So let's continue to do this. So if we do, we'll have k times k minus 4, k plus 1, over k minus 1, k plus 1, times our 9 times k minus 1, k minus 5, k minus 4. Alright, so let's look top and bottom. Is there anything we can cancel out? Well, these k plus 1s can go away, and nothing else top and bottom. So what about diagonally? Well, we have k minus 1, k minus 1, and k minus 4, and k minus 4. So let's write what we have left over. So here we have k over 1 times 9 over k minus 5. And let's multiply straight across. So we have k times 9 is 9k, and 1 times k minus 5 is k minus 5. Keep things in parentheses so you know you can't cancel out those k's. Alright, let's move on to example 3. So now we have 3 terms, but we're going to do it the same exact way. So our first numerator, we can go ahead and factor that out. It's a difference of 2 squares. We'll have x minus 8, x plus 8. Our numerator, well, they have 3 in common. So we'll have to take the 3 out. We'll be left with x plus 9. And for 10x, it's just 10 times x. And for 5x plus 40, they have a 5 in common. So we can do x plus 8. And x plus 9, go ahead and put that in parentheses. And for x squared minus 8x, we can take an x out. So we'll have x minus 8. So let's look top and bottom. Can we cancel anything out? Well, the 10 and 5. Because what's 10 divided by 5? It's 2. So we can cancel that out, and that's left with 2. So let's look diagonally. Well, diagonally, it doesn't matter how far it is. If it's diagonal, we can do it. So we can do this x plus 9 and this x plus 9. This x plus 8, this x plus 8, x minus 8, x minus 8, and this x, and that x. So let's write what we have left over. If there's nothing left, it's just 1. So we'll have 1 over 3 times 2 over 1. And on this right side, it's just 1 over 1 because nothing's left. So we do 1 times 2 times 1 is 2. 3 times 1 times 1 is 3. So our final answer is 2 over 3. Alright, objective 2, dividing. You're going to treat with the same rules as fractions, so we always multiply by the reciprocal. And to do that, we flip the second fraction, and it becomes multiplication. So let's flip everything. Before you do anything, flip it. Alright, so once you flip everything, go ahead and treat it as you were multiplying. So we're going to factor. Our first numerator, we can take an x out. So we'll have x squared minus 9. Our first denominator, we can take an x out. So we'll have x minus 5. And for our trinomial there, we can factor that to x plus 6, x minus 5. And now if we take a look at our x squared minus 9, we don't need to factor that out because why take that extra step? If we just want to rewrite it, we should, because we can go ahead and cancel it out with that x squared minus 9 diagonal from it. So let's start canceling some things out. We can cancel that out. X's, x minus 5, and this x squared minus 9. So if we write what we have left over, there's nothing left over here, so it is just 1. So we'll have 1 over 1 times x plus 6 over 1. So 1 over 1 times x plus 6 over 1 is just x plus 6. Alright, so last example. The first thing we want to do is flip everything. Flip our second fraction. So we'll have 3x squared minus 13x plus 4, x squared minus 16 times 2x plus 8, 27x minus 9. Alright, so once we flip it, we are good to factor. So the first trinomial, I will just factor that out. We'll have our x minus 4, 3x minus 1, our difference of two squareds for x squared minus 16, so we'll have x minus 4, x plus 4, times 2x plus 8, well they have a 2 in common, so we'll have 2, x plus 4, and for 27, x minus 9, they have a 9 in common, so we can do 3x minus 1. Alright, so let's look top and bottom. Is there anything we can cancel out? Well, x minus 4 and x minus 4. Nothing else top and bottom, so let's look diagonally. Well, diagonally, we can do this 3x minus 4, 3x minus 4, and this x plus 4, and this x plus 4. And all we have left over out of everything is 2 over 9.